Hello everyone, let's go to the 128th example. Make a program that reads numbers from the keyboard and stores them in an array allocated dynamically. The user will enter a sequence of numbers with no limit, and the entry of a negative value ends the reading. The data should be stored in a memory as follows. Start with a dynamically allocated array of size 10. After this array is full, allocate a new array of the size of the previous array by adding space for 10 more positions. Copy the previous typed values for this new array, larger area, and free up the initial memory. Repeat the procedure of dynamically expanding with 10 more values whenever the array is full. So let's go to the program and see what is happening here. First of all, I am including two libraries, the stdio.h and the stdlib.h, which allow us to print messages on the screen, use functions such as scanf and malloc. So, moving on, I am allocating two pointers, so the first pointer and the newest pointer, pointing to null, an integer x, I, quantity, and length. The x will be the number that we are reading, and here I am allocating the memory for the first array, and it's a good practice for you to check if the pointer is pointer to a null, because if it is null, seems that the computer doesn't give the necessary memory for us. I will include in all the times that oh my god, here, and here, and then Ctrl C and Ctrl V first. Here is new. Okay, so every time I am asking memory for the computer is a good practice to check if the computer gives to us this necessary memory. So let's move on. This scanf is to scan the first value that you type on your terminal, and while this value is bigger than 0, as the example give to us this information to allocate memory until we type a negative value, ends the reading. So when I type a negative value, we will end the reading. So the first in the position quantity is equal to x, and the quantity will be increased by 1. If the quantity percentage 10 is equal to 0, so seems that we arrived a position that is divisible by 10. So divisors of 10 is 10, 20, 30, 40, 50, and 50, and then these values that we need to allocate more memory for them. So I am allocating memory of the length 10, the first time is 10, and I'm checking if the computer gives to us the necessary memory, and this for is to pass the values, swap the values of the first in the position I to the new in the position I. The I is equal to 0, the I has to be slower than the length, and every time this for loop runs, the value of I will increase by 1. So, just that. I'm free the memory of the first array that I allocate, increase the length by 10, allocating memory for the new length, checking if the computer gives to us the necessary memory, and then I am pass the values of the new in the position I to the first in the position I, and the length minus 10. Why minus 10? Because the new this pointer has 10, and here I increase the value of the length to 20, for example. And if I try to access a part of it is not here, we will break our we will give an error of segmentation fault, because we are asking to access a memory that we don't have permission to access. And then I will free the new array that I create and scanf the next value. And keep doing that until the value is lower than 0, and we will stop. And this for loop is just to print the I quantity, because the quantity will be increasing, and I in position 0, I has to be slower than the quantity, and every time this for loop runs, the value of I will be increased by 1. This printf is just to print the first in the position I, and then I will free the memory for the first in the position I. So let's go to the terminal and see what is happening here. 1, 2, 3, 4, 5, 6, minus 1. As you can see, let's run again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, minus 1. As you can see, the program is working very well. So thank you for your attention. Link for the script is on the video description, and subscribe for regular content.